Good morning, and thanks for joining this talk. I'm going to talk about ArcGIS opportunities with cloud native technologies. It's going to be a high-level discussion on technologies related to the cloud and ArcGIS. So I'm John Waterman. I'm the CTO at GCS. We're based out of Missoula, Montana, and we're a geospatial IT services company. I personally recently have been focused on AWS and ArcGIS technologies. So this is definitely high level, and I'm going to back it up a little and build a little story here and eventually get to the ArcGIS part. So just bear with me. So first of all, cloud native. What does cloud native mean? It's really just a concept and a way of building new architectures in the cloud. And they really evolve around this technology, microservices or containers, if you've heard of those buzzwords, microservices or containers. And they're often built on these things called managed services or serverless offerings. And these are technologies that really have become very popular with the cloud. So the cloud enables us to have these cloud native architectures using microservices a lot easier than it would be to do this all on-prem. So today, or in the past and continuing in the future, people are developing monolithic applications. So this is the opposite of a modern architecture. And so it's this deep, connected architecture where you have different layers for user interface, business logic, a service layer, a database, and everything is tied together. And for most people moving into the future, this is a fine way to go. And this is a fine way to go for smaller applications, smaller businesses. But a modern architecture on the other side is this microservice architecture, where really you take your business logic and you develop your code in different microservices for each piece of your business logic, and you deploy that separately. And what that allows you to do, solve a couple problems, which number one is probably scalability. If you have scalability issues, a microservice architecture would help you. It also has other benefits as well, such as updating code. You can bring down an individual microservice very easily, deploy new code, bring it back up. These microservices could be developed using different technologies and all working together. But there are definitely some drawbacks. And number one, it's way more complex to develop a microservice architecture than a typical monolithic architecture. You need technical resources and staff that understands that. Cross-cutting concerns is a major challenge as well, which cross-cutting means how these microservices have to interact with each other and keep state or session. So that all needs to be managed. So there are definitely challenges with microservices: complexity, security, and the service mesh, which is this interaction or orchestration of all these microservices working together. So it's not for the faint of heart right now. So most people, when they move to the cloud, they're really moving from this, they're doing a lift and shift, if you've heard of that. Commonly, that's thrown around a lot. So a rehosting, where you just take your current ArcGIS server and put it into the cloud, and you do get to take advantage of cost savings and security and a lot of things that come free with the cloud. But as you're in the cloud after a lift and shift, often people will start moving and taking advantage of more of these managed services, and moving towards more of a modern architecture. So what does cloud managed mean? So cloud managed are these services that cloud vendors, Azure, AWS, Google, they all have separate quote unquote managed services where they do a lot of maintenance for you, make it a lot easier for you. So you can really build applications without even thinking about a server. So upgrading the OS, or oftentimes a lot of security concerns or networking concerns, and you pay as you go often. Serverless is kind of a subset of a managed service where really you don't know where your code is installed on. You don't care. Your code could be running anywhere, could be running alongside other people's code. But basically it just works. And really you can, at the most basic level, you can upload a zip file with some code and deploy it, and it works beautifully. So modern architectures are really built on top of these cloud managed offerings and serverless technologies. So an example of a managed service is AWS CloudFormation. And so it's in this bucket of infrastructure as code. So you really have a text file in JSON or YAML, and basically you can build your infrastructure with just one text file. And so Esri makes available these CloudFormation templates, so you can quickly build a single machine deployment all the way up to a highly available, disaster recovery type of architecture. So this is an example of a managed service. And this is an example of the most basic AWS ArcGIS CloudFormation template. So it builds all this infrastructure out. It's not only just the server, but it's also the networking and the certificates and everything that needs to get installed and deployed for an ArcGIS enterprise deployment in the cloud. And so you can think of monolithic currently, ArcGIS Enterprise. All your GIS services and everything is running on just one box. And if that box goes down, then really your site, everything is down, everything breaks. And with regard to scaling, a lot of large enterprises, sometimes you come across scaling issues with large enterprise deployments. And so typically the way you do that traditionally with cloud technology is through elastic scaling or auto scaling. And so you have this picture here where you have one machine and it's servicing requests. And then if this machine gets overloaded or passes a threshold of CPU or memory, another machine gets spun up, a gold standard image that has the exact same services as machine one will get spun up, and it will start to fulfill requests. And then a third machine, and so on. The problem with this architecture traditionally is it takes too long for machine two to spin up with ArcGIS server. And so you could imagine just rebooting your ArcGIS server and waiting for it to come up and your services to come online, depending on how many services you have, how big your box is, and all those different factors. By the time that box comes up or machine two is available with auto scaling, oftentimes these people have left. It's too late. It's not solving the scalability problem that you have. So this moves us to what a microservice architecture is. Really the challenge that it is solving is really scalability. And so ArcGIS, Esri has come out with ArcGIS Enterprise for Kubernetes. And so it runs in Azure, AWS, and apparently on-prem with Red Hat. And so this solves the problem of scalability, whereas instead of all of your GIS services running in one ArcGIS server, you can deploy different microservices or containers, and each container can run a specific service and be managed separately. So this is brand new, and is it for you at this point? Probably not. I would say in the coming years, it's going to become more popular, but it's definitely, it's out there, but it's really meant for large enterprise customers that have specific scaling problems. these customers that have staff that have Kubernetes or microservice experience and support. And down here, I just have some minimum requirements for compute resources in the cloud. And you can see that it takes quite a bit of compute resources as well. So this is definitely for the larger enterprise customers. And the first release of the Kubernetes is just a subset of what enterprise is right now. So it's not even, you can't do everything with Kubernetes now that you can do with enterprise, but it is definitely coming down the pipe in the next few years. I would say it will be more prevalent. But you don't need to, if you want to get started with modern architectures or microservice architectures, you don't need to do the full ArcGIS for Kubernetes. You can start a little smaller with something called, with these functions that run in the cloud. So again, it's as simple as uploading a zip file of Python code and deploying it. And it's very cheap. With AWS, their flavor of this serverless function is called Lambda. And so the free tier is you get 1 million free requests per month, and pretty much you get a lot for free. The other side of this is containers. So they're AWS Fargate is a serverless compute. So it's a managed service that takes care of a lot of the management. If you were to deploy ArcGIS for Kubernetes or some container or a microservice architecture for your non-GIS, AWS Fargate does a lot of the server management and container management, and takes a lot of the skill that you need for background for Kubernetes out of the picture. But I'm going to focus on AWS Lambda. We've used that quite a bit. Google has one called Google Functions. Azure has similar. So whatever cloud vendor you have really has this kind of offering of a serverless function. And AWS Lambda is built on microservices. So the whole architecture behind Lambda is designing functions that run very quickly and stringing them together in workflows to make them disconnected and easy to update and deploy quickly. So what are the use cases? Really, if you're familiar with ArcGIS Notebook, if you've done workloads in ArcGIS Notebook or prototyping or modeling, you're using the Python API, the ArcGIS Python API. If you get to a point where you want to put that code into production scenario, Lambda is a perfect opportunity to do that. So you can literally just zip up your code with very few code changes and upload it into Lambda and schedule it based on an event to fire off once a night, or when data gets updated, it fires off and continues your workflow. So you can think of just the Python API, anything you're doing with the Python API, you want to put that into an enterprise deployment, AWS Lambda. So you can consume all the different APIs that are available with ArcGIS, if it's enterprise online or the new ArcGIS platform, which is a pay-as-you-go kind of scenario with all the same functionality that you get with enterprise and data hosting. You can do ArcPy. You can write code with the REST API, so it doesn't need to be Python. So a couple examples of doing this with Lambda. Number one is you can host a website in AWS without a server, and it's literally pretty much free for the most part. It's very cheap. So you can host your files, your HTML files, your JavaScript images, all your files in something called S3, which is object storage. You can use this API gateway, which exposes your Lambda functions, so your HTML files or JavaScript can call into the server. and call enterprise endpoints or other databases. And so we've done this before a couple times. It's a nice architecture. Probably more popular would be doing server-side processing. Well, let me move to the next one. So this is another example of building a serverless interface for imagery. So you can, the USGS does this for this is an example of the USGS doing this. And so if you're an ArcGIS shop and it takes a lot of resources to build tiles, if you're a shop that builds map tiles, it takes a lot of compute resources. So you can actually use Lambda to do that for you. You can use ArcGIS Server to do it, and you can deploy your tiles in object storage and in S3 without ArcGIS Server, but you need ArcGIS Server to build the tiles. So there's different scenarios that you can take advantage of the cloud to save money on storage of tiles and compute resources. But here's more of an example of what we've done for this. We have this kind of fun website. We're in Missoula, Montana, so a lot of us we go fly fishing quite often with our company, and we built this website called Whacking Fatties, which is a fly fishing forecasting website. And it's built 100% in Lambda, where it goes out to the USGS and it goes down this pipeline. It goes out to USGS, it goes out to NOAA, it goes out to weather services in Canada and in Scotland, and it compiles a 5-star rating for fishability for over 10,000 lakes and streams around the world. And that's deployed in this website called Whacking Fatties. GeoBusiness is a product we have that connects ERP, CRMs with ArcGIS, so Microsoft Dynamics or Oracle NetSuite. And so if you're moving data from one system to another system or need to do some manipulation of data, Lambda is a perfect solution for that. So you can build these different Lambdas. There's other AWS technologies related to Lambda, AWS step functions, which allow you to create a workflow and create conditions and et cetera to help you orchestrate your Lambdas. And if you're into processing raster imagery, of course, Lambda is a great place to do that cheaply. A lot of people are moving to the cloud to process their imagery. So you don't need to procure a server in the cloud to do this. You can use these serverless compute resources and create your workflows, which is much cheaper and much more scalable than procuring a server in the cloud and installing all your software, maintaining your OSs, your security patches, and all that kind of, your networking and all that kind of stuff. So here's another example of using Lambda with the field apps in ArcGIS. So the field apps have a webhook, which is basically a way to signal another application when somebody submits a survey or does something else in the field apps. And so when somebody submits a survey, you can configure it to a URL in Lambda, and it fires off Lambda. And then with those survey results, you can push them into different systems. If it's Microsoft Dynamics, Oracle NetSuite, other business systems that you have, that's a good way to go from ArcGIS to other business systems. And then there are lots of options for serverless for your data store. So I've mentioned Amazon S3, which most people are familiar with at this point. It's object storage, and it's very cheap. And if you have lots of raster data, that's really where people are storing their data now in the cloud, is in these object storage technologies or offerings. Amazon DynamoDB and RDS, Amazon Aurora, or are all different types of data stores that are serverless. in AWS where you can have geodatabases or other type of GIS data. I'm just going to skip ahead here. So with Lambda, you can deploy your GIS workloads, call other ArcGIS APIs. But if you want to store your data, your geodatabase, your enterprise geodatabase in a serverless offering, you can use Amazon Aurora, which is a flavor of PostgreSQL. And so the licensing is very cheap, and it's highly durable, highly available, and it's a lot cheaper than most other offerings. So that is definitely something to look into, and more and more people are doing this with their enterprise geodatabases. But I think I'm going to stop there and just see if we have questions. If people can still hear me, Samantha.
Yeah, thank you, John.
Oh, good.
Let's see if we have any questions in the queue for you. If you would like, you can post your questions to the Huva Q&A. And if there are none at the moment, you can still feel free to pop questions in there. And John, anytime, you can drop in there anytime as well, just to check on the dialogue. A lot of people like to check back afterwards too.
Sure. Sounds good.
All right, well, thank you.
Thank you very much. Have a good day. Thanks.